In earlier math classes, you were asked to identify the greatest common factor of two numbers. And in algebra, you will be asked to find the greatest common factor of two polynomials. We can use a technique that would have been useful for numbers with polynomials. So, well, in this case, monomials. So a technique that we can use to find the greatest common factor of two numbers is just repeated division. So you may be able to just look at these two numbers and identify the greatest common factor. If you can, that's fine. You don't have to show this work. But if this is not something that you can just look at and see the greatest common factor, here is one technique. So I look at these two numbers and don't try to find the greatest common factor. I just try to find any common factor. Two even numbers, I can always say 2 is a common factor. And then what I'm going to do is just divide both of the numbers by 2. 48 divided by 2 is 24. 72 divided by 2 is 36. Since what I have left, that quotient does not, they still have a common factor, I am not done yet. So I'm going to look at these two numbers. I could again divide by 2 since they're even, but I'm going to see that, oh, there's a bigger one that I see right away, which is 6. If you see a bigger one, great. Again, I could have just multiplied by 2, but I'm going to go ahead and divide through by 6. 24 divided by 6 is 4. 36 divided by 6 is 6. I am still not done because that quotient still has a common factor of 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. Only now am I done because 2 and 3 no longer have a common factor at all. Now to use all this work to find the greatest common factor, I multiply together all these common factors in this left column. So my greatest common factor is 2 times 6 times 2. 12 times 2, which is 24. That's my GCF. And now that I look at it, I can see, oh yeah, 24 is a greatest common factor of 48 and 72. 24 times 2 is 48, 24 times 3 is 72, and that is definitely the greatest common factor. Again, this is not required if you can just look at the two numbers and confidently find 24, for example. When we start having variable factors, we can still use this technique. First, starting with the numerical component. What is the GCF of negative 18 and 6? In this case, I can just identify it at 6. But if I couldn't, I could have divided through by 2 and then by 3, and I would have found 6. So the greatest common factor is 6. Negative 18 divided by 6 is negative 3, and the variable factors remain unchanged for now. 6 divided by 6 is 1, so I'm just going to have an invisible 1 and leave it invisible. These two terms, or monomials, still have common factors. They have a common factor that is an x component. That common factor is x to the third. X to the third is definitely a factor of this first monomial, and x to the third is also a factor here. X to the fifth is just x to the third times x squared. I'm going to go ahead and divide through here. So negative 3x to the third y to the fourth divided by x to the third is just negative 3 y to the fourth. X to the fifth divided by x to the third is x squared y squared. And I can see that I have one final common factor, y squared. Y squared is a factor of y to the fourth, y squared times y squared, and obviously it's a factor of this one. Dividing through, I have negative 3y squared and x squared. Here my GCF is just the product of that left column, 6, x cubed, or x to the third, y squared. Again, many of you will be able to identify this GCF without doing this work, and that is fine. But if you want to use this strategy, I find it really useful. Now, when you're asked to find the GCF of a polynomial, that's just going to be the GCF of its terms. So exactly this process here with an addition sign. GCF of 16, 24, and 32. My first thought was 4, but I can see actually a bigger greatest common factor of that numerical factor of 8. Because 16 divided by 8 is 2, 24 divided by 8 is 3, 32 divided by 8 is 4. And then dividing through by that constant, I still have x to the fourth, x to the third, x squared. I still have one common factor of those terms. That's just x squared. X squared is a factor of x to the fourth, x to the third, and x squared. So 2x to the fourth divided by x squared is 2x squared. 3x to the third divided by x squared is 3x. And 4x squared divided by x squared is 4. I am done because these three terms do no longer share a common factor. There's no x term here, and then there's no common factor of the numerical coefficients. So my GCF is just 8x squared, and I could have maybe just identified that looking at it. The great thing about actually doing this division is it helps us right away when we are asked to write the polynomial in factored form. So the polynomial in factored form is just going to be the GCF times whatever we get here at the bottom, this remaining quotient. So whatever we get when we divide the polynomial by its GCF goes in parentheses in factored form. So 16x to the fourth plus 24x to the third plus 32x squared in factored form is just the GCF 8x squared times this quotient, 2x squared plus 3x plus 4. This is kind of like working backwards from multiplication. If I multiplied this out, 16x to the fourth, 24x to the third, 32x squared. So when I multiply it out, I can see that my factored form is correct. I just have to make sure that this is in fact the GCF. Here I can also just go ahead and write the factored form because I did all this work above. So the GCF that I'm factoring out is 6x to the third y squared. And then inside my parentheses will just be this part down here, negative 3y squared plus x squared. A lot of students quickly are able to go from here to here in their head without doing any work at all, and that is totally fine. I would just suggest that you do go ahead and at least mentally multiply out to make sure that you factored correctly. Please pay careful attention to the directions. If you're just asked to find, like here, the GCF, let's go ahead and divide by 2. And maybe you can do this without any work at all. That's fine. But if you're just asked to find the GCF, the answer here is 2x. For these same numbers, if I'm asked to write the polynomial in factored form, that means not just finding the GCF, but writing the polynomial as the GCF times whatever you need to multiply it by to get this original polynomial. So 2x times 5x gives me 10x squared. 2x times 3 gives me 6x. Same thing here. If I'm just asked for the GCF, I'm going to go ahead and straight away divide by 5x. That gives me 3x squared minus 1. So this is the GCF. 5x is the GCF. Factored form is the GCF times whatever I need to multiply the GCF by to get back to the original polynomial. 15x to the third minus 5x. This one I didn't do above, so I would need to go ahead and identify that GCF. Oh, no, it's different than this one. I would need to go ahead and identify that GCF, which looks like it's going to be 2x, just 2x. And then what do I need to multiply 2x by to get to 4x to the third? What do I need to multiply 2x by to get to negative 16x squared? What do I need to multiply 2x by to get to 18x? And there I'm done. I know I'm done because this multiplies out to 4x to the third minus 16x squared plus 18x. And then also this is in fact the GCF because there's no common factor of these terms.